Everyone likes data. Everyone likes not freezing to death. So why not combine the two? Today I want to show you how to build a Wi-Fi attached temperature sensor for under $10. Let's introduce the star of the show, ESP8266. This is a microcontroller, so basically a small computer with a Wi-Fi module, a complete network stack, a bunch of GPIO pins. What this means in simple terms is this. You can attach this really cheap device to any kind of gadget, sensor, etc., and also to your network. And then you can either talk to it via the network or have it talk to other network devices. I, for example, like many people, have my own server. I like your server. So obviously I log my temperatures to my self-hosted enterprise-grade monitoring software. Okay, so quick introduction. This is a microcontroller, which are usually programmed via serial. It's a very, very simple protocol. It just uses two wires, one to send data and one to receive data. Now I'm using this FT232R USB to serial adapter, but actually this port, as you see it right here, is called NodeMCU. You can see it actually has a USB port. And it has a USB to serial adapter. It even has a voltage regulator, all built into this package. So theoretically, you can just attach USB here, and you get power and you get serial. So you don't even need this thing, but I'm going to use it anyway, so you see how it works. Now, you might be able to see I put this here on 5 volt, so that means it outputs 5 volt. Be careful, this board has two voltages, has 5 volt input and has 3.3 volt output. So you have two things you can do. Either you take this 5 volt output of this device and put it to V-in over here, right? Or you output 3.3 volts and you put it on 3.3 volts. Don't put 5 volts on the 3.3 volt pin. That will burn the board. That's happened to me more than once. Now the setup is very simple. As I already said, as a serial, so we have two cables. We have one called TX and we have one called RX. RX for receiving and TX for sending. Now they have to cross over. So the RX pin from this thing goes to the TX pin on this thing and vice versa. Then, of course, we have ground and we have power. Don't forget to put ground on this thing as well, because otherwise it will not be able to communicate. Right? So this thing has to have the same ground as this, or it will not work. Then we have our temperature probe here. This is a DH222. This is a very simple device. It only has 3 pins, as you can see. Has plus, minus, and out. So all the data goes via out, and that's it. Now the whole setup is very simple. Really, we just attach plus of this to the 3.3 volt of this. We attach ground to ground, and we attach the data pin to one of the GPIO pins using this green cable here, and attach to this over here, D1. Make sure you don't use D4, I think it is, because D4, that's for flashing. When you want to flash this device, you have to put D4 into ground. Into ground, not into 3.3 volts, or actually 5 volts in this case. All right, to ground. Not that I ever ruined the device because of this. And that's actually already it. Most people are very scared when they hear the word programming, but you don't need to be scared. Programming this device is actually super simple. All the code is on GitHub, link below. But I would encourage you to try and understand what's going on, because the real power of this thing is that for something like $5, you can attach anything in your apartment to Wi-Fi. That is super powerful. You can measure whatever you want. You could attach it to like an LED controller or whatever and have a website where you can click on and it changes the color of your room. You could have an app on your phone, talk to this thing, and do whatever you want. And it's actually not hard to do at all. This is Arduino IDE, which actually supports this board, this ESP8266. You can use any software to write your code. Personally, I will use VS Code in the future, but I wanted to show you the basics here because this is kind of the default. First, before we can start, we need to set some stuff up. Under File and Preferences, we have to add this board URL here, which is in the description. And then we can install the board under Tools, Boards Manager. And here you can just search for ESP and install this packet right here. This is both the firmware for the board as well as some basic libraries which we will use in the future. Once you've done that, you can go back here to Tools, Board, and now you have this ESP and you can select your version. Now when you buy your board, it will tell you which one it is, hopefully in the specifications. I have this one, but you have to select the right one. Also make sure that all the settings are correct. Again, that should be in the spec sheet. Usually for these ESPs, for example, upload speed should be 115/200. All right, last boring step, we need to install a library for DH222. So this is the temperature sensor we use, and the library will allow us to talk to it. So if you just search for DHT22, there are many libraries. I use this one by Adafruit. You can use different ones, but then the code will be different as well. So if you want to use this code, you need to use this library. Okay, onto the code. First things first, at the top of the code, first thing should always be importing the library. So library is just a piece of code that someone else wrote because we are not smart enough to do it ourselves. In this case, we're using the DHT library, which we just installed, and we're using this library, ESP8266 Wi-Fi. This actually handles all the Wi-Fi setup, connection, etc. Next, we use the define statement to define some constants. In coding, much like in mathematics, we have this concept of a variable. A variable has a value, like x is 5, right? The thing is, in coding, you can change the value of a variable in code, so you can reassign it a different value. And that means you have to store that value somewhere. And that somewhere is RAM. Now, the problem is that devices like this, they don't have much RAM. In fact, they have laughably small amounts of RAM. So you actually have to be mindful what you put on these devices, in the RAM of these devices. And you should really think, this value that I have, does it change during the code execution or not? And you will find there are a lot of things that don't change during code execution. For example, the name of your Wi-Fi password, the pin that you attach the temperature sensor to. These probably don't change during execution of the code. So these shouldn't be variables, they should be constants. Now you can go through your code and just say, every time you connect to Wi-Fi, you can just say, connect to a Wi-Fi with this name and with this value. You could hard code it. But hard coding stuff in is a very bad idea, because if you ever want to change it, it's a lot of work. It's hard to maintain, right? Let's say you reference a pin that you attach your temperature sensor 5 times. If you ever want to change it, you have to search for that pin in your code and replace every single occurrence. That is really annoying. Luckily, there is a way on these devices to define a constant. In Arduino IDE, there is a shorthand for this. It's called define. You can see that we have define and then a name followed by a value. Now what happens when I compile this is that the compiler just goes through this code, and every time it finds, for example, DHT pin, it replaces it with a value 5. So here, down here, we have DHT pin, and that would be replaced with the value 5. Whenever it finds DHT type, it will replace it with the value DHT22. Down here we have DHT type, it will be replaced with DHT22. So what I've written here is the same as writing it like this and using define. The difference is that by writing it up here, it's really easy to change it, and I don't have to go through my code and find all the occurrences of DHT pin and DHT type. Now for these two, it's not so complicated because these are the only occurrences. But something like debug, for example, we will use a lot. Every time we have serial output, we're gonna use debug to be able to turn serial off. Because serial, in this case, will run with 115,200 characters per second, which sounds really fast, but it's actually incredibly slow for a microprocessor. So it will have to wait a ridiculous time, again, for a processor to send us this text. That actually slows it down significantly. And so you want to turn this off when you are in quote-unquote production mode. So the basic constants that we define here is the pin and type of the DHT. It's the rate for serial, the baud rate. It's whether we want to be in debug mode or not. And it's the SSID and the password of our Wi-Fi. Now I made these up, of course. You have to put in your SSID and your password. Now to the actual code. First, we initialize our DHT class. A class is just something, we call it an object, that has properties and it has things it can do, so-called methods. How it does those things, I have no clue. The library, this library up here, the DHT library, takes care of that for us. All we need to know is that the documentation says we need to give it the pin and the type as arguments. ESP itself expects us to have two functions. Now, functions are basically pieces of reusable code. So we can just call this function and it will execute this code. We can call this function and it will execute this code. ESP expects us to have a setup and a loop function. They have to be there. If they're not there, you can't even compile. You will get an error immediately. Now, what those do is really straightforward. Setup runs once on boot and loop runs continuously in the background as fast as possible. Once we have done that, at this point in the code, we have a thing called myDHT, which is an instance of the class DHT. And by the way, you can give it any name you want, that we can use to read the temperature, read the humidity, or compute the heat index. So again, what will happen? We boot this thing up, it will go through this, it will run this begin, whatever it does, it doesn't matter, we don't have to understand it. Our value debug is set to true. That means that this code will be executed and it will begin the serial connection and start with an empty line. And then it will talk to this DHT class to get the temperature, the humidity, and the heat index. Finally, once we get all these values, we also want to output them somehow. So we can use serial print for that. Print just puts stuff out on the serial console, and println does the same, but it creates a new line at the end. You will see what this means when we look at this output. And again, this is in an if, so that's a conditional execution. We only execute this if debug is true. Debug is constant with define, so right now it's true, so when the compiler runs through it, it will replace debug just with true, like this. True equals true, that is correct, and so this will be executed. Now we are ready to get our code on the device. It's very simple. Just connect your flashing pin to ground. Then you click this button here that says upload and wait for the compilation. Once compilation is done, you will see that it wants to connect. At this point in time, you have to hit the reset button really quickly to allow it to connect, and then it will begin uploading the code. Once the flashing is complete, either you have a programmer that does an auto reset. I don't. If you don't, you have to just hit reset. Before you do that, go to Tools and Serial Monitor. Make sure it's on the right rate. And then we hit reset. And we can see that it will output temperature, humidity, heat index. Here now you can see, by the way, the difference between print and println. So you see we print this text, temp, humidity, heat index, this. Then we print temperature slash humidity slash heat index. Temperature, humidity, heat index. And then we have a println at the end, and that actually creates a new line. Without the println, it's all in one line. So that's cool and all, but of course, our idea is to get this information via the network. We are a website. So we need to do two things. We need to connect to our network, and we need to create a website on the device. All we need in the code to connect to Wi-Fi is to use Wi-Fi begin down here. And if you look in the documentation, you will see it requires an SSID and it requires a password These, again, are constants for us. And that's it. Again, the library takes care of all the magic in the background. I don't really know how Wi-Fi works. It's pretty complicated. You have to send keeper lives and all that stuff, right? But this Wi-Fi library does it all for us, so we don't have to worry about it. I also add a couple more debug messages here, as you can see that we're connected and to print the IP of our device. This is actually kind of important, so you know what the IP address of the device is. Of course, you could check your DHCP server if you have one and know that works as well. So after flashing is complete, we go back to the serial monitor and we reset our device once more. You see it's connecting to Wi-Fi, you see it connected, and I got this IP address right here. And you can see we can ping it, so it actually has network connectivity. As you can see, so far working with this device is super simple, and as turns out, adding a web server to it is not much harder. By now, I do hope that your first impulse is to search for a library. In this case, it exists. It's called ESP8266 web server. And similar to DHT, we just create this object, the ESP8266 web server object. We call it server. It wants a port to connect to. In our case, it's HTTP, so it's port 80. Next, we have to define what the web server actually does. We just want to get a very simple document back that gives us the temperature and the humidity and the heat index. But to understand how that works, we have to understand how HTTP works first. So you might have thought that HTTP is very complicated, but this is actually it. This is an entire HTTP request and this is an entire HTTP response. It's very simple, so it's just plain text. It looks exactly like this, including all the spaces. It's a verb. In this case it's get, then it's a space, then it's a path. In this case the path is slash, but it can also be, for example, this, right? And then it's a version of HTTP. Currently we are at HTTP 2, but we're actually getting 3 soon. Then you can have headers, so you can say stuff like accept, encoding, whatever, right? So here you can say stuff like, hey, I can decode gzip and blah, 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 right? But they are optional, they don't have to be like this. And this is actually a complete request. Now you can have optional data that you send, even on a request. In this case, you have an empty line and then you can send data. Now, you don't send data on a get request, you can send data on a post request though, or on a put, right? So the way this works is there are a couple verbs and they tell the server what you want to do with the path. So get means you want to get the path, you want to get the information of the path. Post means you want to put something there, you want to submit some data. Let's think back to my WhatsApp example. If you are sending a message, you might make a post request to some WhatsApp server, send message path, right? And then it might be your message here. Right, this might be how it actually honestly looks. And then the response is very simple. It's the version, then it's the status code, and then it's the status code written out. So 200 stands for OK. Then again, you can have headers, and then again, there's an empty line, and then there's the data. And that is literally it. In our case, we only care about receiving information, namely temp, humidity, and heat index. So for that, we only need a get request. So we can define this with a server on method. It requires a path, then a verb, and then there's a function that gets executed when this path gets a get request. Now I want to make this clear. You can have different requests on the same path. So I could have a get and a post, for example, and then use different functions. But right now, again, we only care about a get. Now I call this path slash measurement. You can call it whatever you want. You then require a server begin. Again, I added a debug statement here. The way this works, whenever the server gets a get request on measurement, it will execute this function, return measurement. Now the function is here, and you can see actually that loop is now changed, and it basically copied over what we had in loop before. Instead of returning it over serial, we will now return it over HTTP. In this case, we are using JSON format. JSON stands for JavaScript Object Notation and is widely used for communication between servers. So for example, if you start WhatsApp, then you get a message. It's probably a JSON object that says, hey, you got a message from this ID, this timestamp, and this is a message, right? JSON is used for all kinds of things. One of the most widely used, well, not protocols, but message formats on the planet. The cool thing about it, it's machine readable by pretty much everything. So if you use JSON, you can use some program to read this website, to read the output of this HTTP request and use it. Now JSON has a specific format, and doesn't really matter what the format is, you can just look it up. This looks very complicated. It will become clear what it is once we actually flash this. Finally, this is the actual response, server sent. 200 is a code, so 200 means everything's okay. And then we set the type is JSON, and then the actual response as a text. The actual response is this. Finally, the loop again has changed. Again, I removed these three things, but you also need this server handle client, which basically is what responds to us. Right, once the flashing is complete, we reset the entire thing. And then we just open a browser and we go to our IP address /measurement. And as we can see, we get temperature, humidity, and the heat index in this nice JSON format. And you can see when I refresh it, it will hopefully change. I guess I was too fast. The DHT is pretty slow, but you can see that it works just fine. And that's actually it. Now we have an ESP8266 with an attached temperature sensor that gives us the temperature, the humidity, and the heat index via JSON, which we can access with any piece of code we write. Next step, of course, is to store this in some database so we can see historical data. Thank you for watching, and tune in next time.